First, let's do it with the logistic regression. Let's find the accuracy. If the accuracy is not good, let's embed it with just no, wait. We need to embed it with a TF-IDF model and then logistic regression. That gives the best accuracy possible. So let's actually embed it with TF-IDF model. So let me send you the code that I wrote for
I
TF-IDF.
I have the TF-IDF vectorizer here already.
Oh, you do? Okay,
Yeah.
why don't you put it in?
Give me a second.
Okay, so put the TF-IDF model, and then okay. So if you already have, I mean, I have the vectorizer. I'm gonna try with. Have you ever heard of Distilbert?
Hmm?
Distilbert.
You've mentioned it. I don't really remember doing it though.
Okay, so I was using PyTorch. Like I gave up on like tensor. Like okay, so I was using a torch model
Mm-hmm.
uh, with a tensor board. So basically, you import Torch, you import Torch XML, XLA, and then I just imported sklearn. I did the whole test train split. I did 70 to 30 first. Then I tried with I tokenized the comments, and then I just used your pre-processing. But the problem with your pre-processing was it was reading a lot of these texts into an integer format. Like the sentiments were all like they're just int, like they're all zero and ones. But the problem is the text they were all being written into string. Like instead of string, I was getting what do you call integer. So I just converted all those
Wait,
like
say
just use.
again?
So I got all the text in terms of an integer format.
Huh? What does that mean?
Like okay, so when I was trying to do some more pre-processing, okay,
Yeah.
what was happening was that I kept getting the same error
Mm-hmm.
that int cannot be transferred to like this function cannot be applied to an int when I was doing it on text. So
This
like df
function cannot be converted to text. You sure?
no, yes no let me tell you df text okay
Mm-hmm.
in df text dot apply
Fam,
I
you're
applied
not
some
even in my
pre-processing
list of
right
live
um,
channels. LOL.
it kept giving me the error that all the not all but it was in an int format for some of them. So I just what I did was did I just put str like string format for all the comments or for all the texts,
That
and then
works, yeah.
yeah I
Code
just
says is
resolved it
now
like that,
live.
and then I
Streaming
was using
science
batch
and
sizes.
technology.
So I
Day
had
2 of
16
ignition hacks.
batches
Also
for
need
all the
Minecraft
feature
help later.
generation and all, and the only problem is it wasn't
Message me
in
when
the
you
end it
free.
didn't you know
Hmm.
it kept like it ran for 2 hours and using a GPU and a TPU and my CPU, none of them worked. Or like it didn't work. The kernel just failed because it was running for 3 hours. So I think let's just stick to our basic ML algorithms.
So you don't want to use TF-IDF because
No, no,
I just finished the TF-IDF training.
no. We are using TF-IDF.
Okay.
That's the best vectorizer for text, at least.
Alright, well,
I'ma go out, we'll be back later, probably around 8 maybe 9.
So
hmm.
let me run this on my Jupyter notebook. I'll show you that.
Alright. So have you get pulled the newest version of what I've done?
Yeah, yeah, I did.
Okay.
I'm gonna try that on my Jupyter notebook and I'll tell you what I got.
Yeah. Yeah, so we need to also get some more feature extraction in it. So we can't just have the TF-IDF vectors. We also need to have like some things like, I don't know, length of the actual uh, string and stuff like that.
Why do we need that?
No, because it's just extra data that we could use.
Okay, sure. I was
Yeah.
thinking. Okay, so this is what I thought of last night. So for one way we could train our sentiment model is apart from PFIDF and logistic regression, we could use certain negative. We could create an array of negative words, and for if a sentence contains that negative word, it can also be given a weightage of like a negative classification, like a logistic regression weight.
But we don't know those negative words.
Oh no, basic negative words like don't, like I've been looking at the data set, don't always associate it to zero. Like, so just look at the data set.
I don't know, but
And then,
just let me check the new CSV that I've outputted because uh that has the cleaned version. Some of the common words are not even in there. Like there's some stop words that are just removed. So we'll see. Give me a second.
you know what? Let's not do that idea because now I'm looking at some data points which has like no like yep especially has its sentiment of zero. That's weird.
So I'm assuming that 0 is
Negative
negative
and one is
and 1
positive.
is positive. Okay.
Yeah. Let me try your. Okay, got it. Now I have my pre-existing logistic regression code. Let me just copy paste it.
Yo.
Yo, what's up? Stanley, hello.
I assume this is for division delta?
Division sigma actually.
What the hell? I gotta realize that I could not convert string to float. What does that mean? String floating points. What the fuck? I gotta try something else.
Alright, so okay, yeah. So did you see the new CSV test? That CSV? That's the clean version of all the data. Okay, so the new CSV test.csv, that's the cleaned version of all the data.
Yeah, I got that.
Okay. So yeah, even yep especially has been in there, but stuff like for example, let me pull this up. Yeah, so no way I don't want the tour to end, right? Those words just became way don't want tour end.
Did we remove the stop words?
Yeah, I removed stop words.
Okay, let's not do that.
You
Then
don't
keep the
want
stop words.
you don't want to remove the stop words?
Yeah, that's not good because think about it. If you remove the stop words, words which are actually important, which determines if something needs to like not be there or getting removed. So let's just remove the stop, remove the removing stop words. Let's keep stop words. We just need to have the text clean in the sense like it's easy for the TF-IDF model to vectorize it.
Yeah, but here's the thing. If we don't remove stop words, there's going to be a lot more words that we have to look through that essentially are just filler words.
But again, what I'm saying is those words, those filler words, might be important in determining the sentiment.
Let me check out what the list of stop words is. Stop words list.
Words like no and stuff like that, that's not good for a sentiment analyzer.
Okay, so stop words list is as follows. There again shouldn't, doesn't,
No,
further
we need
itself.
it. Doesn't is okay. Doesn't is an automatic zero. We need this.
No?
Yeah. No. Look at the data set. We're gonna have words like
I don't know,
this
just
doesn't.
let me just run through this. Okay.
Okay.
Doesn't further itself that why aren't it didn't had your had don't just VEA himself he themselves more same wasn't these, but like these are all common pronouns and contractions.
Yeah.
Like I don't think, yeah, the word no is there, but not that many things are dependent on the actual word no. Because like here's the thing, we're doing context based, we're not doing, oh, this word here instant. We need context based,
Right. And that
so that removing the stop words helps with the context.
how exactly though? If you're
because
removing
because like for example, you said doesn't, right?
yes.
Doesn't really doesn't isn't a specific negative word.
Okay.
The sentiment will be near 0.5 if on the 0 to 1 scale for doesn't. So we need to remove that for any irregularities and keep the words, for example, like, where am I looking? Like filthy. Like for example, the user Matthew Day said, haha, the girl, filthy purse, like yes, unfortunately. That stuff stays. Unfortunately, that's a negative word. Okay, do you need the word I? Do you need the word a? Do you need the word they? Do you need the word, like, do you need pronouns? You don't need them, right?
We don't need them, but I'm just thinking there's
Exactly. It helps remove, it helps to like clean the text of all of most unnecessary words that don't pertain to the actual thing.
no, that makes sense. But what I'm just saying is if you look at the original data set, it makes at some points it just doesn't make sense why. Or like sometimes we could have a misclassification of hey that's a positive statement, but although it's given as zero. Like yep, especially it's given a zero, and I'm like wait why is it given a zero?
Exactly, stuff like that. So we have to
No, we can eliminate all stop words, but I'm just saying if we do, we might lower the accuracy when we're doing it. So okay, how about this? Let's
no,
just eliminate the stop
here's the
words
thing,
for
removing
now.
stop words increases accuracy because you're removing like extreme words that have been flagged as insta negative, insta positive, right?
Yeah.
But some of those words can be used in a positive sentiment. Like okay, I'm gonna look at negative sentiments, right?
Okay,
Just
now how about this? Let's just keep. Okay, let's just remove stop words and let's see the accuracy with logistic regression. I just want to see
yeah,
inaccuracy. And
we yeah. I just need to get that set up as well.
yeah, so once we have an accuracy, then I think it will be better to.
Yeah. Okay, so far what I've done so far is I haven't, so what I'm doing is I'm having the cleaned text, the clean text function separate, right?
Okay.
Because the TF IDF vectorizer can use the analyzer equal clean text, and as
Okay.
it does the vectorization, it cleans the text. Like it cleans
Oh,
text and
I
then
don't know.
vectorizes,
Oh, I
right?
don't know.
Yeah, so
I just thought it just. Okay, wow.
Yeah, so right now I've done the TF IDF vector for X test, which is a
Okay.
testing thing for the X for the text.
Okay. So let's.
So that tokenizes it and does the entire thing. That's only 5,000 data points, so we need to do the rest as well.
Right.
So question, do you want to do the TF IDF vectorizer first before the train test split, or what?
Now let's do the TF-IDF vectorizer, and then let's just have pure numbers to play around with.
No, okay, so right now what I did was I train test split first, right?
Yeah.
And then TF IDF just the X test so far. Do you want to do TF IDF before splitting?
Yeah, no. We'll do TF-IDF before splitting, so the entire data set after being cleaned, we'll vectorize it with the TF-IDF model, and then we'll use train test split, and then we're going to use a train test split with logistic regression to calculate the accuracy. And we're going to just keep doing that with SVM logistic regression. We're going to try different combinations, and the one with the best accuracy, we're going to use that as our final one.
Okay.
And if we can, and we'll just experiment around with, like, if this one, like TF-IDF with, then we'll try keeping the stopwords to see how much accuracy changes by, just for the sake of it.
Okay, I'm going to do some edits. So instead of doing X test for the TF IDF vectorization, we're going to do the just the data frame, and specifically text, right?
Yeah.
Right.
I'm gonna try logistic regression meanwhile, just without any vectorization. I don't know why the classification isn't working, but I'll get it. Two features. We don't need the, what do you call it, the username as a feature.
Yeah, so I didn't touch that at all. I haven't touched the ID or the username. I've only touched the text and the sentiment.
Okay. I'm going to get some tea. I'll be right back in a minute.
But
Thank you for following Stanley_Gen.
Alright, I'm back.
Are you back?
Yes, I'm back.
Alright.
Understanding why.
Alright, I'm waiting for the TF-IDF vectorizer to analyze and clean text, which may take a while.
Okay. Meanwhile, you can. Oh,
Yeah.
wait. Just look at my screen. Here.
Yeah, what's up?
This is the. I was just trying to use sklearn's logistic regression, and I used the train test split, which is given by you over here,
Mm-hmm.
and I tried fitting it with the sklearn logistic regression. I got this error. Cannot convert string to float. Didn't. I think this is the one
Yeah,
where
okay, go up, scroll up to your logistic regression. I want to see what you're doing.
this is a really basic one.
No, scroll up to the other one. The other, like,
Oh, this.
yeah.
No, this one I didn't use it. This one I didn't implement it yet. This is just a logistic regression class that I was thought of using.
Okay.
I coded it up a while ago, so we're not gonna use this right now.
Yeah, so
We're
we need to convert strings into numbers, and that's what the TF-IDF vectorizer does.
okay. So let's just wait for the TF-IDF vectorizer to work.
Yeah, and then from that you can try logistic regression.
Yeah, so we'll just use this line of code essentially.
Mm-hmm.
Okay, sounds good. And oh yeah, let me show you what I was doing last night. So this is Distilbert. So here's what I was trying to do last night. And
Distilbert?
yeah, it's a deep neural network classifier. So
But don't we need to create the algorithm?
Hmm?
Don't we need to create the algorithm?
no, Distilbert, it just classifies with the raw data it gets and like it extracts features. We need to do the feature extraction, which I did over here.
No, I mean,
And
like, for div sigma, we need to create the algorithm, right?
yeah, we
So using Distilbert would be, like,
Distilbert is
against...
to again check for classification. The algorithm. Okay, look, what we need to do for ignition hacks is that we. Let me show you. Yeah, 424. Where is the thing to work? Just give me a sec. Here. Here. We need to right. We need to program an AI model that predicts the sentiment for a given sentence. For example, logistic regression with TF-IDF, we're essentially programming an AI model to predict sentiment. So once the logistic regression classifier works, I think what we need to do is we need to just come up with better ways to clean the text. We just need to observe the data the way it works. We need to just write code like if you see it, don't before running the logistic regression classifier. Here are some presets that you can classify beforehand. Like if you see a don't or a no or any of those, we can have an array of negative words that we observe from the data set, and we can just write that out, and we can just pre like code it, as in like pre-train the model. If you see an automatic negative word, classify it into a negative, classify it into 0. If you see a positive word, classify it into a 1. Actually, we don't even need to create the. Actually, no, we do need to create a. Now, once we do that, that's when we can implement logistic regression. And if a logistic regression finds that a misclassification based on our pre-created model, we can put that as a weight to rule the logistic regression. That's where we are essentially creating an AI algorithm, because we're assigning weights to the logistic regression classifier. So once it gets a weight, we can determine what we can do. We can either just go with our pre-assumed model, or we can just classify it according to the logistic regression model. And the best part is if it's classified into a logistic regression model, we can, I don't know, we just need to check the accuracy. At that point, it's just experimentation. I just want this TF-IDF vectorizer and logistic regression to work, and then we can just after that we'll just play around with it, and whichever one works the best, we're gonna try it out with a judgmental set.
Yeah.
Do you
Only
know how to do that?
only
Like
thing is, I
applying
just need to figure out how to run the train validation and test into the logistic regression, because I don't remember what exactly I did for the class. Let me
let's
open this.
look into this. Let's look into how to implement this on the judgment file. Like once you train it. Actually, no, that's easy. I just want the CSV file to like we just create a new column and like for every text that is just see where it classifies into and assign 1 or 0 based on that. We
Yeah.
need to code it up. Wait, why don't you look at how we can code that up right now? Because we're not waste time.
Okay, so I did logistic regression here. Binary classification, so Gaussian quantiles. Implementing logistic regression. Do you want to try a polynomial transformation or no? Or is it just logistic regression?
Just logistic regression. We'll see based on. I just want the vectorizer work. Then we can decide what we can do.
Yeah, because right after logistic regression unit in my class, we did polynomial transformation, and we took the Gaussian quantile set, right? Which essentially meant that in a line of data points, it's a straight up line, right? There are 3 sections. The outer 2 sections are one class, and the middle section is one class. And polynomial regression helped figure that out.
Okay. That our problem here. Let's see how that works.
Oh geez, I forgot that we had to do actual manual polynomial regression.
How far is it?
Hmm?
How far is it done?
I don't know. It's still doing the TF-IDF factorizer.
No, it shouldn't take too much time because we still need to.
Yeah.
Because we're doing the final judgment set and it's due at 9. Do you think we can finish by 9?
Oh yeah. Alright, let me just look this up. Python C progress of TF-IDF factorizer. I just added the verbosity statement, so we'll see how the TF-IDF vectorizer actually does stuff. It does not have it. Okay. Alright, never mind. We don't have a verbosity statement then.
Yeah. Yeah, I'm gonna do this on my interview. Did you sleep well?
What's happening?
Did you sleep well?
Yeah.
Good.
Right.
You ever used IMB Learn?
What?
IMB Learn module.
No, I haven't used that.
Okay. I'm gonna use
Hi,
it.
Balthia.
What's up?
Nothing much. Did you sleep? You like passed out yesterday.
Yeah. I slept.
That's good.
Yee.
Best into the beach. Oh. Dude, for the new CSV test, why is some of the texts in unnamed column?
What do you mean?
Check this out. Here.
Yeah, what do you mean?
Like text over here, and then there's unnamed over here.
What the fuck?
Why is that happening?
I do not know. Let me check.
I didn't even realize that.
Is it the very
normally-
bottom?
Yeah, it starts at 2999712. I mean, if it's the last five, I might really have the assumption that there are a lot of stuff up there like that too. Let's just do tf.head for 50,000 and see what happens. How many points are here in this data set?
Almost 1 million.
Oh damn. Here,
I'm
Okay.
scrolling.
1,000. I need to count them. Man, 3 million? Uh-huh.
Okay, I don't see where you're getting that. It shouldn't have done that. I don't know what happened. Are you sure it's not like just moving it over?
I'm not sure. Like I'm doing it. Okay, let me just see it at 150,000 and let's see what's happening. Okay, even at 150,000, it's fine. Let's increase the number to 2 million. Yeah, it's fine even at 2 million. That was at 200,000.
So it's probably just
Okay,
moving it
so-
over. It's not exactly like misplaced. I think yeah, because it's supposed to be right. Nothing. I didn't change anything other than the actual text.
Okay, at 2 million it's happening. No, but it's not happening at 150,000, 200,000, 800,000. I tried all these numbers, but it's happening after 2 million.
No, that's
I
the
mean, I
thing.
can't
It's
point.
that's not supposed to happen
Okay, okay. Okay, let's
because
just okay.
like
Okay, that
the only thing I've done in that, right?
yeah.
I have the line df train text equals df train text dot apply clean text. I've only touched the text, nothing, no other column.
Okay.
So I'm just confused as to what the hell happened.
Okay, okay. It's okay. Let's do this. Df dot drop na, and we'll see what happens. If suppose the last few, like the last million entries, are going into the wrong place, we can just drop them off because we have enough data to like actually run an AI model.
Yeah.
'Cause
I'm
first
gonna
one
send this to you.
properly. Okay. Interesting. Oh wait, never mind, never mind. It just happens. I don't think anything's wrong with our pre-existing code.
Okay, yeah, that's what makes sense.
Yeah, because I was looking at this other notebook from like my internship.
Mm-hmm.
One of the people that I work with did the same thing.
Well, did
Oh,
I
there's
finally figure out what you meant by yesterday?
What?
I finally understood what you meant by JSON format.
I can't hear you. What'd you say?
I said I finally understood what you meant by saying JSON format.
I heard JSON format.
Yeah, I said I finally understood what you meant yesterday.
Okay.
Took me a while to understand that. Because I've never really done stuff like this, so like it's...
Hmm.
because Ollie speaks pure tech.
I am
No,
Tech Master.
Yeah,
69.
but it just I finally understood why, because you wanted to send the GET request as a JSON format, because that's just the easier way.
Exactly.
Got it, yeah.
So if you made the front end send everything in a specified format that the back end can just parse given the format, there's no need for the actual linking part.
Okay, yeah,
Yeah,
I got
because
that.
it'll just be an endpoint.
Yeah, I got that, yeah.
Do you need to have lowercase equals?
Because I feel
two,
like
lowercase
if you had to link, it would be so hard in like the framework of Django, because there's so much restrictions and like you have to follow that particular framework.
Yep. You a single hit?
Do you want to keep the lowercase equal to true or lowercase equal to false?
I did that in my clean text. I turned everything lowercase. Do I need that or no?
I mean, no, I don't know. Like, we need to see based on the accuracy. The initial review of the data set, lowercase or uppercase doesn't matter. But if you have like a text like with like a capital NO, then and if it's a 0, with the small NO, the sentence can be a 1.
Yeah, so what
That
I've
would-
done so far is I've so I removed the @ mentions, I removed the hashtags, I removed retweets, I removed links, right? I also then applied
Ellery.
lemmatization. Hello, devil. I applied lemmatization, I lowercased everything, and then I removed punctuation. And then I
Okay.
removed stop words.
Okay, sure. That works.
Yeah. God damn, this vectorization is taking forever. Let me check if Colab does it faster.
Colab has even more limited. Okay, what are you using? Are you using VS Code?
Mm-hmm.
Okay. I'll try with Colab then. I did it with Colab before. It was extremely slow. Actually, no, Colab can tell you the progress on how fast it's taking. So do that.
Valdithia,
Mm-hmm.
what's XML?
It's just another format of storing data, like JSON.
Okay.
Same with YAML.
So like, okay. So that could also be used as a way for. Actually, no, you can't.
XML, no, because JSON is the network-based data organization system. YAML, XML, those stuff, that's meta language. So that's stuff needed for like programs to run properly, or like a specific configuration for programs to run.
So that's like more like front end, right? Like HTML, XML.
No. XML usually is for applications, not exactly like display purposes.
Okay.
So it's not a front end thing.
Okay. What about XAMPP?
Hmm?
XAMPP.
XMP?
Mm-hmm.
I haven't dealt with much in that, but again, it's not a orthodox network procedural system.
Okay. Apparently, an AJAX request uses an XML object request.
It does?
Apparently, yeah.
Yeah,
Because
it's
like,
not orthodox, because nowadays most people just use what am I trying to say?
I get requests with the JSON file.
Or just any request with JSON.
Yeah. Yeah, but I'm just saying an AJAX request just uses an XML HTTP request object, which is created by JavaScript.
Hmm.
I'm just trying to get a better hand and hold of what the hell is going on, so I get more understanding. I do another project.
Alright, I'm doing a TF-IDF factorizer with logistic regression. We'll see how long this takes.
No, try running the IPYNB that we have right now.
Okay. Oh, no, that, okay, that would be cool again. No, it's the same thing. No, I already ran it. Did you learn machine learning in this class that you took in the summer?
Mm-hmm.
Do you like it?
I would have liked more time.
What do you call it? We had much less time to do.
Yeah.
Oh no.
Why, what's up?
It's running really slow because it's also running distro burp, and I forgot to shut that down. Any flows unnecessary tab. I'm gonna call you on the
Isn't that
phone.
running on Colab?
Jupyter Notebook.
Oh, on VS Code?
Oh no, just Jupyter Notebook, not even VS Code.
Oh, like a separate
My VS
program
Code,
called
my
Jupyter
VS Code
Notebooks.
is not. Yeah, my VS Code is not able to import pandas because it says pandas is not available. And I tried doing brew install, conda install, every type of install, and I think messed up on installation. So I'm just doing everything on Jupyter Notebook, and I just push my code from VS Code. I'll just copy paste it. We don't need to spend time on fixing that right now. We'll
Yeah.
do that later. It's really annoying. It takes forever to run. Hey, can I share someone else's CPU power to run this?
I do not know. Okay, so I've set it up so that it's running on Colab.
Okay.
I don't know if the Colab is gonna
No.
take TF-IDF and do it faster, but let's see. Here, I'll share this to you.
Okay.
Yeah, share.
Meanwhile, I'll get started on our AI model again.
Am I doing it to Soundwave, Rohit?
Yeah.
Okay. Yeah, there, I sent it.
Okay, once again, I'll get it. Hello?
Yeah, what's up?
Wait, no. Huh? Yeah. Okay, bye. Oh, God. Okay. The kernel keeps dying. Let me use. I'm gonna reset it. I'm gonna reset this. Okay, how do I improve? Like, how do I improve processing power? Ball.
I do not know.
Because it keeps dying out because it says lack of CPU.
When is it do when is it doing what?
Now look, it's in the kernel in the Jupyter Notebook. It keeps dying because we're doing a pretty big data set, and I'm using a TF-IDF vectorizer along with a logistic regression model.
Hmm. You could try using GenSim. Apparently, it's faster.
Jensen?
Yeah, GenSim.
Wait, where to begin? Shut down. Let's shut down everything. Do you think having too many Chrome tabs is also a reason why it's not running fast?
Nah, that shouldn't change anything because this is running on Google servers, not ours.
No, no, not Colab, like Jupyter Notebook.
Maybe.
Okay. I don't know what to do then. I'm gonna run this in Colab then, the code I have.
Hmm.
You know what? Google Colab says that some you're also running it, so I'm just gonna run it on that. Okay. Okay, let's wait for the vectorizer to
Oh,
run. What happened?
it's done.
Tell me.
It's much faster.
On Colab?
Yeah.
Colab. Can you show me?
I shared it to you.
On Colab.
Okay, so with using the vectorization, right? We get 788 columns for each data point.
Oh damn. Okay.
Like each yeah, each entry of text has 788 features.
Wow.
Yeah, that's
Yeah, I'm looking at it right now.
I shared the
That's a lot.
IPYNB to you, so you can try using that. Okay, let's continue with this.
Okay, let's start training. Oh my goodness.
Okay. Just need to do logistic regression from here on out, right?
Yep. I can send you the code I have, or give me a second. My laptop's off.
Hmm.
It's overheating.